Okay, good morning to all. This is Vinarajan Patnaik. I am going to discuss about the cryptography and network security, chapter number 7, network security and the VPN. So first move to the articles of this chapter. Brief introduction of TCP/IP, firewall, IP security, virtual private network or VPN. First come to the TCP/IP model. This TCP/IP model. First about what are the going to the TCP segment structure. First a little discussion about what is the TCP/IP. TCP/IP model is to determine how a specific computer should be connected to the internet and how data should be transmitted between them. And it you can say it helps you to create a virtual network when multiple computer networks are connected together. And the purpose of TCP/IP model is to allow communication over large distances. So this is a very strong protocol among all the networking protocols. And this TCP/IP stands for Transmission Control Protocol or Internet Protocol. And the stack is specifically designed as a model to offer highly reliable and end-to-end byte stream over an unreliable network. Then the TCP segment structure come to the segment part. TCP segment consists of data bytes to be sent and a header that is added to the data by TCP as so. This is the segment structure: header, data, and source port address, destination port address, sequence number, acknowledgement number, and header length, reserve bits. These are the segment structure. So in the first stage of segment structure, source port address is a 16-bit port address or 16-bit field that holds the port address of the application and that is sending the data segment. Destination port address is also 16-bit. That means both source and destination both are 32 bits to the combination. That means source port is 16-bit, destination 16-bit. That means total 32 bits. Next, sequence number, then it is 32 bits. That means it is a field that holds the sequence number, the byte number of the first byte that is sent in that particular segment. It is used to reassemble the message at the receiving end if the segments are received out of the order. That means what is the use of this sequence number? Now when the data is sent through the different datagrams or data packets, every packet having a sequence number, because at the receiver end it is not mandatory, or you can say that the segment 1, that means the segment 1 packet will be reached first, then segment 2, no. There is no compulsory and hardcore rule and regulation that the packet 1 is reached first, then packet 2 is first. Maybe the last packet will reach first, then the middle packet will reach second, then whatever, any random series can happen. So at the time of the integration, there will definitely the packet number 1, then followed by packet number 2, then followed by packet number 3, then followed by packet number 4. So this is the sequence number. So this sequence number is required for the integration of the data packets at the receiver end. Acknowledgement number, it is also the 32 bits. 32-bit field that holds the acknowledgement number and the byte number that the receiver expects to receive next. It is an acknowledgement for the previous bytes being received successfully. So this is known as the acknowledgement, whether the byte will be or whether the data packet will reach successfully in the receiver end or not. The acknowledgement is generated from the receiver end towards the sender. Next is a 4-bit of header length. This is a 4-bit field and that indicates the length of the TCP header by number of 4 byte words in the header. If the header is of 20 bytes, that means the the length of TCP header, then this field will hold 5 because and the maximum length is 60 bytes. Then it will hold the value of 15. This one. Control flag. Next is your control flag. Control flag. What are the control flags? Now that URG, these are the control flag. URG, SCK, PSH, then RST, SYN, FIN, FIN. These are the control flags. These are the 6 1-bit control bit. The control connection establishment, connection termination, connection abortion, flow control, mode of transfer, extra. Their function is URG, urgent pointer is valid, URG. ACK, acknowledgement number is valid, and PSH, request for post, RST, reset the connection, synchronize sequence numbers, FIN, terminate the connection. So these are the flag bits, control flag bits. These are the 1-bit control flags. URG, urgent pointer, SCK acknowledge, PSS, request for post, and synchronize sequence number, FIN, terminate the connection. So these are the control flags. Next is your window size is 16 bits. This field tells the window size of the sending TCP in bytes, window size. Checksum bit, everybody know that. What is the checksum? Checksum is for the error control. It is mandatory in TCP as opposed to UDP right now, because checksum bit is not present in the UDP protocol, but it is mandatory for the TCP protocol. Next is your urgent pointer, which is also the 16 bits, right? And this field valid if the URG control flag is used to point to data that is urgently required, that needs to reach the receiving process at the earliest, and the value of this field is added to the sequence number to get the byte number of the last and urgent byte. So these are the TCP/IP frame structure. You can say this is the segment structure of the TCP/IP model, but here this is another reserved 6 bits. It is used for future use. So this is 16 bits. This is 16 bits. This is the entire sequence number is 32 bit. Acknowledgement also 32, and this is the 16 bits, and this is 4 bits. This is 6 bits. And other 6, that means 1, 2, 3, 4, 5, 6. This is another 6. That means this is also 16 bits, 16 bits, 16, 16. And options are padding up to 40 bytes. So these are the entire TCP segment structure. Next come to the firewall. Firewall can be defined as a special type of network security device or a software program that monitors and filters incoming and outgoing network traffic based on a defined set of security rules. It acts as a barrier between internal private networks and external sources. So these are the firewall system. As a special type of network security is a device right now, and it is controlled by a software that monitors and filters incoming and outgoing network traffic based on a defined set of security rules. And next is these are the types of firewall. Besides, there are many other types of firewalls depending on their features. These are the packet filtering firewalls and application level gateways or proxy firewalls. Next, the primary purpose of firewall is to allow non-threatening traffic and prevent malicious or unwanted data traffic, for protecting the computer from viruses and attacks. And a firewall is a cyber security tool that filters network traffic and help users to block malicious software from accessing the internet in infected computers. So for today's class, this one, and from next you are discussed about the other points regarding firewall. Thank you to all.